To understand the current state of enterprise AI, look at one staggering statistic. Right now, 95% of enterprise generative AI pilots completely fail to reach production. When a highly anticipated pilot is quietly shelved, the natural instinct is to blame the technology. We assume the underlying models simply lack the reasoning capacity to handle complex business logic, and that we just need to wait for the next major release to solve our problems. In reality, today's models are remarkably capable. The billions of dollars currently evaporating in abandoned proof of concepts result from self-inflicted systemic operational traps. We've identified 8 distinct traps that routinely kill these initiatives, but if you trace them back to their origin, every single one of these pitfalls is a symptom of 3 deeply held illusions organizations maintain about how artificial intelligence actually works. To survive this transition to AI-driven architecture, enterprises have to stop waiting for smarter algorithms and start dismantling their own operational illusions. The first hurdle is the illusion of knowledge. Many organizations assume that simply indexing and vectorizing a massive codebase or document library makes the AI a useful, knowledgeable participant in the workflow. This demonstrates pitfall 1, building before grounding. Without context, models rely on generic memory, producing hallucinations. Feeding them massive source code triggers trap 2, context without intent. Code lacks the why behind design, leaving AI to guess logic entirely from syntax. And if you try to design a system through private, unmonitored chats with an AI, you'll encounter trap 7, the sycophancy trap. Large language models are statistical engines optimized for user satisfaction. They suffer from sycophancy, meaning they will echo your ideas back to you and validate terrible design decisions, rather than offering objective, critical pushback. Unguided data inevitably breeds highly confident errors. To be effective, AI requires an explicitly defined semantic layer, mapping out operational boundaries and business intent before a single line of code is written. Next, we have the illusion of capability. This is the persistent, magnetic instinct to build a single, all-purpose AI agent by endlessly injecting it with more tools, larger prompts, and broader responsibilities. Trap 4 is the everything agent. Feeding an agent everything reduces accuracy, as instructions inside a bloated context window degrade. The pivot is to think smaller. Deconstruct complex workflows into a coordinated network of specialized sub-agents passing clean, discrete data packets. This need for specificity also applies to data retrieval, leading to trap 6, the general-purpose RAG trap. Building an Ask Anything chatbot over your internal documents lacks a defined purpose limitation. Under privacy frameworks like the GDPR, operating without explicitly bounded data processing turns your entire architecture into an immediate legal liability. The final capability pitfall is trap 8, the thin wrapper. Slapping a simple user interface over a third-party AI model provides zero long-term defensibility. Exposing model selection to your end users destroys operational consistency, leaving your application entirely vulnerable to the next native model update. Developing enterprise-grade capability requires highly constrained, legally compliant, and deeply integrated engineering that moves beyond the limitations of a generalized wrapper. Our final category deals with the human cost of these deployments, the illusion of speed. This is the dangerous imbalance created when AI accelerates your production pipeline, but you fail to scale your downstream verification processes. We can see this imbalance in trap 3, the velocity trap. AI assistants increase raw code generation by 2.5 times, yet actual software delivery only increases by 10 to 15% because security scanning, testing, and compliance remain at a human speed bottleneck. Because code creation has exponentially outpaced human review, organizations accumulate massive verification debt. Highly paid senior engineers are transformed into slop janitors, spending their days reviewing and fixing generated code rather than writing actual logic. This directly causes trap 5, comprehension and ownership debt. Faced with an overwhelming surge of massive pull requests, developers succumb to code review surrender. They begin YOLO merging large agent-generated changes without rigorous manual review, simply to keep the production pipeline moving. A severe psychological shift takes place. Developers devolve from active authors to mere curators. When a production incident occurs in code they no longer understand, they lack the professional responsibility to debug it, choosing instead to gamble by continuously rewriting prompts, hoping the AI will eventually guess the right fix. Chasing sheer speed without human comprehension creates a completely unmaintainable system. You are effectively trading short-term velocity for a long-term operational collapse. The mechanics of software engineering have permanently inverted. Raw code is now incredibly cheap to produce, but software maintenance, rigorous verification, and mistake correction are more expensive and critical than ever before. The days of casual vibe coding, generating entire applications without deeply understanding the underlying architecture, are officially over. We have entered the age of strict AI governance and hard operational boundaries. The mandate for enterprises is clear. Stop chasing the newest models and avoid token maxing just to see what an AI can do. Instead, pivot your entire strategy toward intent-driven development, where human design dictates the exact parameters of machine action. To make this work, organizations must drastically expand their budgets and project timelines specifically for human verification, the deployment of specialized QA agents, and continuous, rigorous testing loops. Generative AI is not going to replace software engineers, but the future belongs entirely to those who can design the robust, disciplined systems required to keep the machines honest.